Okay, so what if I told you that the most valuable thing in the entire universe isn't gold, it's not diamonds, but it might just be something growing right in your backyard? Today, we're going to completely flip our understanding of value on its head. We're going to look at our world through the eyes of an interstellar traveler and discover what the true currency of the cosmos really is. So let's just start with a really simple comparison. On one side, you've got everything we consider wealth here on Earth: gold, platinum, diamonds, the stuff we literally fight wars over. And on the other side, a pine tree. We see it as lumber, maybe a nice decoration for the holidays, but to a galactic civilization, that tree could be a treasure beyond all imagination. And the answer to that question? Well, it changes everything. It kind of suggests that while we've been digging deep into the earth searching for treasure, we've been completely missing the real prize, just sitting right there on the surface the whole time. To really get why, we first have to look at our own treasures and see them for what they are on a cosmic scale. And this brings us to what we can call the gold paradox. I know, it sounds a little harsh, right? But to a species that can hop between star systems, our most precious materials are, well, they're just common debris. They're not the product of some rare, miraculous event. Nope, they're just the predictable, elemental leftovers from really violent cosmic stuff, like dying stars. I mean, you have to understand, the universe is literally swimming in this stuff. Take the asteroid Psyche 16, for example. Scientists think it holds more gold and precious metals than have ever been mined on Earth. So, for a really advanced civilization, finding gold isn't a challenge. It's just a matter of stopping at the right rock. It's not rare at all, it's just raw material. And here's the key takeaway. These materials, forged in the heart of a star, are fundamentally simple. Gold is just a heavy element. A diamond? That's just carbon atoms in a really repetitive, predictable pattern. They're all products of raw, sterile physics. And that's the crucial word right there: sterile. So, if an advanced civilization isn't after simple, dead elements, what are they looking for? What is the one resource that is truly, unbelievably scarce out there in the vast, cold emptiness of space? And this is where the whole paradigm just shifts completely. See, real value isn't found in shiny, simple matter. It's found in information. It's all about breathtaking complexity, the kind of intricate structure that it takes a living planet billions of years to create. You just can't mine that from a dead rock. So that brings us to the heart of it all. It's not our technology, it's not our cities, it's not even us. It's something way more fundamental and way more widespread. The answer? The most complex and cosmically rare thing on this planet is life itself. It's biology. And the most widespread, dense, and easily accessible form of that biological complexity, you guessed it, it's a tree. We really have to reframe how we think about this. A tree isn't just a plant. It is a solar-powered, self-replicating organic machine. For millions of years, it has perfected the art of converting raw starlight into these incredibly intricate, ordered structures. It's a factory of almost perfect efficiency and elegance. This comparison really says it all. A diamond is just carbon atoms in a simple repeating lattice. It's informationally poor. But wood, oh man, wood is woven from cellulose and lignin. These are staggeringly complex polymers that have billions of years of evolutionary data packed into their very structure. No supernova could ever dream of making something so intricate. And for a civilization that's advanced enough, this complexity isn't just beautiful, it is incredibly useful. Forget burning it. They could have a process to unlock the massive chemical energy stored in those molecular bonds. By isolating the complex polymers in wood, carefully unraveling them, and starting a controlled bioreaction, they could generate a burst of energy powerful enough to fuel an interstellar jump. Our forests become their high-density, 5-star refueling stations. And this completely reframes Carl Sagan's famous pale blue dot, doesn't it? From this new perspective, Earth is no longer just a lonely speck of dust. For an alien ship running on fumes in a desolate star system, our planet isn't just a pale blue marble. It is a vibrant, glowing emerald beacon, an all-you-can-eat buffet of pure biological energy. Just think about it for a second. The constant, powerful energy signature of global photosynthesis, the incredible density of life in our jungles and forests. To an alien sensor array, that biological signal would be a flare in the dark, so much brighter and more interesting than the faint heat signatures of our cities. Our biosphere is basically shouting its existence across the void. So this This radical shift in perspective leaves us with a pretty profound new understanding of our role, not just on this planet, but maybe in the entire cosmos. We have spent our entire history digging into the ground, searching for wealth, for rare metals and shiny stones to hoard away in safes. But the irony is just staggering. This entire time, the truly priceless artifact, the one thing in this whole corner of the galaxy that is genuinely rare and complex, it's been growing all around us, in our parks, our backyards, and our vast ancient forests. Just let that sink in for a minute. In this huge, overwhelmingly silent and lifeless corner of the universe, we are the keepers. We're the guardians of this incredible biological treasure. And that kind of redefines our role from just being the dominant species to being custodians of a genuine galactic rarity. Which leaves us with one final and maybe a little haunting question. If they ever do show up, looking to refuel at the only Emerald Station for light years around, what are we going to tell them we did with all their fuel? It's something to think about. Thanks for joining me.